Good morning. Today we will solve this problem and start with this problem. The problem is given that analyze the amplifier as shown in the figure below and determine its voltage gain. Okay. This voltage gain is actually small signal voltage gain, small V0 by small Vi, and assume beta is 100. So, what we will do? We will first draw the DC circuit. First step, this is the first step. So, what we will do? This AC circuit, this AC source we will not consider. Okay. So, we will replace this and draw the rest of the circuit. So, what will be the circuit? This is VCC, this is resistance, this is my transistor, this is my output, and this is my input, right, and this is grounded. Okay. So, what are the values given? This is 10 volt, this is 3 kilo ohm, this is 100 kilo ohm, let us say this is RB and say this is VB is equal to 3 volt. So, what is the first step? We will define VB, right. Let us consider that VB is equal to 0.7 volt. So, you know this voltage, you know this voltage. So, first step is find IB. IB is equal to VBB minus VBE by RBB. Okay. First write my name, then you put the values. VBB is equal to 3, this is 0.7 and this is 100 kilo ohm, this is in voltage, take care of the unit. Okay. Then this is 2.3 by 100 K, right. So, how much it is coming? 23 microamp. You take care of the unit and points. So, this is 23 into 10 to the power minus 6 ampere. Okay, right. Next step is, this is first step. What is second step? You find IC. IC equation is beta IB. So, it becomes 2.3 milliampere. You multiply it to 100 and take care of the this unit micro to milli conversion. Third step, you find Vc or V0. Okay, Vc or V0. What is the equation? VCC minus IC RC. Okay, find out the value. 10 minus 2.3 into 3K. 2.3 actually it is milli. So, if you write milli into K, they will cancel out. See what is happening, 10 minus 2.3 into 10 to the power minus 3 ampere and K means 3 into 10 to the power 3. So, these two terms get cancelled. Okay, these small things you can take care. So, what is the value? 3.1. Now, tell me this voltage is 0.7 and this voltage is 3.1. So, this collector base is in reverse bias or not? So, collector base is in reverse bias. Okay. See, this is simple, right? All of the steps, this is my first step. You consider this base voltage is 0.7. Then second step is find out the IB. Once you get IB, you come to IC. Once you get the IC, you get the V0. Okay. Next is what? So, what we arrive that the BJT is in active mode, that is confirmed. Next step is draw the AC equivalent circuit. So, what is the AC equivalent circuit? Now, we will not consider the DC sources. So, only AC sources, RBB will be there, but VBB will not be there, BJT is there, emitter is grounded, and this collector resistance is also grounded. And where is the output? This is the output, right, collector terminal is our output. So, what we just did, we consider this node as ground, you see this is ground. So, if it is ground, we can flip it and draw. So, that is I have just done, I have just flipped it, but the connection is same, right. If I draw it here or here, both same. Now, can you tell me what will be my V0? Suppose IC current is flowing through this. So, what will be the V0 will be current drop into resistance IC RC. Now, IC is this current, right. So, KCL says this plus this should be 0. So, this should be IC or minus IC? Minus IC, then KCL is satisfied, right, IC plus minus IC is equal to 0. So, actually my output voltage is minus IC into RC. This collector is flowing IC. So, this node, if we do the KCL, the current flowing through this resistance and current flowing through this collector, their summation should be 0. So, how much current is flowing? Minus IC, clear. Next step is we will replace this BJT with its small signal model. So, what is this? This circuit remains same, right, this circuit remains same, only we will replace the BJT with its 2-port network. So, what will be the circuit? This circuit remains same. Input side, how we will model it? Base emitter resistance, right, base to emitter R pi. So, this is my base terminal, this is my R pi. So, this voltage, say this is V pi. Terminology you can use anything, small Vb, small V pi. So, this terminal is grounded, this is my emitter. From collector to emitter one current will flow, that is Gm times this voltage. So, if it is V pi you write it V pi, if it is Vb you write it Vb. Next, R naught will be there, right, but you can, if values are not given, then you can neglect, right, there will be some R naught. So, at this moment early voltage is not specified, so we are neglecting it. So, what will be this collector terminal is having RC to the ground. Which node is output? This collector node is my output, clear. So, what you will have to do? You will have to find this voltage. So, first step is to find the V pi. So, what is the equation for V pi? See, this circuit you can redraw like this. This is my Vi, this is my one resistance, this is my another resistance, ground. This node I want, right. So, what it becomes? Potential divider. So, this is my R pi, this is my RBB. Always start with the nomenclature, then it will be easy to frame the equation. Do not just directly start with the values, okay. Follow the procedure, then you can, while cross check, if there is any mistake, it will be easier to debug. So, your equation, this is, suppose I current is flowing through this. So, this voltage drop is I into R. So, suppose I current is flowing and this voltage is R pi. Now, what is I current? Total voltage by total resistance, clear. So, this is I got it. Next what I need, this current and this current. So, if this is IC, this is minus IC. So, just find out IC, IC is equal to this current. What is IC? So, let us write IC is equal to Gm into V pi. What is V pi? This equation is equal to Gm, in place of V pi I will write this Vi R pi by RBB plus R pi. Okay. Next step is find out V0. What is V0? V0 is equal to this drop. What is the current? Current is minus IC. Resistance is, so this is just Ohm's law, right? V is equal to IR. Okay. So, what it becomes? Minus Gm Vi R pi RC by RBB plus R pi. You see, now V pi is replaced with Vi, right? I have replaced V pi with Vi. So, I can get the small signal voltage gain, which is V0 by Vi. So, Vi I will just divide this Vi. So, what is my gain? Minus Gm R pi RC by clear. Next step is I have to calculate the values of this. So, what is the value of Gm? IC by Vt. What is the IC you have calculated? Just cross check. IC is equal to 2.3 milliampere. So, this is 2.3 milliampere. Vt is roughly 25 millivolt. You see milli get cancelled, right? 10 to the minus 3 get cancelled. So, how much you can calculate? Milliampere per volt. Yes, you can do that. You can do that, milliampere per volt. You keep this. Okay. So, it will be 2.3 into 10 to the power 3 by 25 milliampere per volt. Okay. That you can do. So, that when you multiply with kilo ohm, that kilo and this milli get cancelled out. Anything means both are okay. You can, but you should keep you should note down. You shouldn't write it and then write ampere per volt, then it will be wrong. Okay. Now, next is R pi. R pi is equal to beta by Gm. What is the beta value? 100. Gm you just calculated, right? So, you put it here. Rest of the stuffs you know, RC you know, RBB you know. So, you can get the small signal gain, that is V0 by Vi. That says that how much it will be your small signal, how much it will be amplified. This value will tell you that how much it will be amplified. Okay. So, this is our complete problem. So, how we started? We have a complete circuit, we just draw the DC circuit, then DC values we are calculating. After that we draw the AC circuit and we draw the 2-port network. In this circuit also you can directly do, but it is better to initially you better to draw the model and solve it. Okay. I hope now onwards you will not have any problem in solving AC gain. So, this is just drawn here. So, all of these values are calculated. What is RE? RE is equal to Vt by IE. Okay. So, they have calculated RE, they have calculated Gm, R pi. Okay. And you can calculate the total voltage gain, that is minus 3.04 V by V. This unit, I am, you please always take care of the unit, always write down the unit. This gain is unitless, right, voltage by voltage. So, it is unitless. So, you write it V by V or without any unit. Okay. Always specify the unit, otherwise you will make mistakes. Sometimes you use kilo ohm, sometimes you use ohm and you forget to multiply. GM you can write in milliampere per volt, millisiemens. So, this is our complete circuit with the coupling capacitor. So, if I ask you to draw a C amplifier, this is the complete circuit. Okay. It can have current source, it can have a resistance, that depends on the type of biasing. So, what are the characteristics? My input impedance is R pi, right. So, it is moderate to low and R out is also moderate to high. It is not that in op amp, what was our characteristics? Input impedance is high, output impedance was low, but we are not getting this. So, still this can behave like an amplifier, but not a perfect amplifier, is not it? Ideal amplifier, it should have high infinite input impedance, but so what we are getting? Moderate. Output impedance should be 0, but what we are getting? High. So, it can be a intermediate block, but not a complete amplifier. So, we may need input and output stage to design a complete amplifier. Why? Because of these considerations. What is our consideration? That input impedance should be infinite, output impedance should be 0, that is not satisfied. Gain is high and gain is also negative, right, means phase inverted, 180 degree phase inverted. So, we can tell it 180 degree out of phase. Okay. So, these are the characteristics of the common emitter amplifier, right. So, this is performing the analysis on the circuit. So, directly on the circuit we can draw this R naught. So, it will come that V 0 will be minus Gm into V pi into RC parallel R naught. So, directly on the circuit, when you will be expert, you can, without drawing the small signal analysis, you can have a idea that what could be my gain. Okay. But initially prefer to draw the circuit. So, next is finding the with the emitter resistance. So, without emitter resistance, what we found? AV is equal to minus Gm RC, that we found, right. So, with emitter resistance we will be having a decrease in gain by 1 plus Gm RE types. Okay. This RE, this is the extra resistance, right. So, multiply it with Gm, okay, add 1. So, this times your gain will be reduced. So, what will be your modified gain? Minus Gm RC divided by 1 plus Gm RE. This is without RE, with RE. Okay. Why? Because negative feedback, in negative feedback what happens? Your gain is reduced. With positive feedback what happens? Your gain is increased. Next is without RE, what is your RIN? If you do not have RE, if you look from this side, you see the R pi, right, and with RE, the times it is reduced gain, the times it will be increased input impedance. With RE, your RIN is now 1 plus Gm RE times R pi. Now, as if we neglect this, see, we said that there is a relationship between R pi and RE, right. there is a relationship between R pi and RE. What is that? Small RE. This is beta plus 1 times, because emitter current is beta plus 1 times base current. So, emitter resistance should be beta plus 1 times less than base resistance. Okay. Okay. So, we solve this, right. How to arrive this? We solve this. If you want, we can do that again. So, what is your IB? IB is equal to say VI by R pi, and I is equal to VI by, this is a T network. Okay. This is equivalent to your 2 port network or hybrid pi network, but sometimes T network is useful, sometimes hybrid pi network is useful. So, it is forming the, in case we have a RE, so T network is useful. So, in Cedra, if you see Cedra and Smith, they have followed this model, but you can do the same thing with your pi model also, no problem. So, this is VI by, what is the total resistance? Small RE, emitter side resistance is small RE plus RE. Okay. And what is your output voltage? V0 is equal to, suppose minus IC is flowing, so minus IC into RC. IC, write it in terms of IE, because we are calculating IE. What is that? IC in terms of IE, alpha I RC. What is I? Put this value, minus alpha VI RC by RE plus RE. Okay. Take that RE common, minus alpha by RE VI RC by 1 plus RE by RE. Now, you see alpha by RE is my GM. So, this is minus GM RC VI, and 1 by RE, if you neglect alpha, 1 by RE, this also you can tell that it is roughly GM, because alpha is close to 1. So, inside also we are making it. So, this is not exactly, this is approximately. So, what will be your AV? AV is equal to V0 by Vi. So, divide this term with Vi. So, what you get? Minus GM RC by 1 plus. So, we told that our GMRC is reduced by 1 plus GMRE. How to derive that? You write the current in terms of emitter current and write the emitter current by this expression, then you will get it. You see, all steps are very simple. Do not skip any step, then it will be difficult to debug. If you follow step by step. First step is ICRC, second step is write IC in terms of IE, second step, third step is replace the IE with VI, fourth step is replace the alpha and RE with GM, that is it. So, that the same thing is done here. So, you can find the IE, you can find the Rin, and you see the resistance ratio with Rin and without Rin is 1 plus GM times RE. Okay. So, this is my feedback factor. So, RE is the feedback resistance, but GM is coming as internal gain, GM into RE is internal gain, and this is how you derive your. Okay. So, what are the takeaway? That input resistance is increased by a factor of 1 plus GM RE. By the same factor, gain is reduced. So, your nonlinear, for the same nonlinear, the input signal Vi, as if it is Vi is now more, right. So, overall voltage gain is less dependent on the value of beta. So, previously you see it was GM RC. Now, if you neglect the 1, this is GM RE. So, your AV is equal to minus. So, no dependence on GM, and GM is a factor of beta. So, no dependence on beta. Then what is the advantage? We do not have any control on beta. This is technology parameter, right? This parameter we do not have any control. What is the meaning? Then we do not have any control on gain. Suppose temperature is changing, so our gain will also change, we have no control. I have asked you to design a amplifier with a gain of 10 or minus 10, you have designed that, but sometimes you are seeing that it is having a gain of minus 9, sometimes it is having a gain of minus 11. Then what I will say, the user, suppose some user have asked you to design a amplifier for his purpose, and you have designed that with all the honesty. Now, when the user is going to use it, he is telling that, sir, sometime I am seeing 10 gain, sometime I am seeing 9 gain, sometimes I am seeing 11 gain. So, what he has paid you for the design. So, what he will say? It is a bad design, I have paid you, but your gain is not constant, it is varying all the time. Then how you can explain him? It is not my fault, it is the fault of beta. Will he listen? He will not listen, right? So, what you need to do? You need to make this gain as much independent of your technology parameter, because you have no control. But this resistance, suppose due to temperature their values will also change, but if as it is a ratio, both of them will change in the same direction, right, or both of them will fall by the same value. So, their ratio remain constant. Now, we have a control. So, that is the advantage of using negative feedback, that we are reducing the dependency on the beta. In last class I told you one problem, that you designed an amplifier, now beta is supposed to change from 100 to 110, and what you see that your amplifier entering in the saturation. So, gain fall. Okay. But if you use just a simple solution, what is that? A resistance, you put a resistance in the emitter, just putting this a simple resistance in the emitter, you can overcome. Why? Because of negative feedback. Why negative feedback? I hope you can all recall. Can you recall? Previously my circuit was like this. So, it was my VB, right. So, I have no control. If this is increasing, my IB will increase, my IC will also increase. Now, what I have modified? I have put a resistance. Now, you see this is my VB and there is a emitter voltage now. Previously emitter voltage was 0. So, now suppose IC is increasing, so will increase the IERE drop. So, V will also increase. Suppose IC is increased, so what will happen? IE will also increase. So, what will happen? IERE drop will also increase. So, my VE will increase. Now, what is my VB? VB minus VE. So, if V is increasing, what will happen to VB? This is a minus sign, no? So, if V is increasing, what will happen to VB? It will decrease. Now, see, if VB is decreased, what will happen to IB? Decrease. If IB is decreased, what will happen to IC? Decrease. So, you see this is going to counterbalance this, clear. So, this is a negative feedback. You will be saying that okay, where is the feedback? It is not getting back, right. but it is getting back like this way. In the circuit you may be okay, it is just a RE is connected to ground, where is the feedback? Feedback is happening this way inside the circuit. Okay. Generally what we see, that something is coming back, right, that is our feedback conception, right. So, it is happening through the voltages, the voltage it is generating is reducing my input voltage effect. Okay. So, if I ask you to draw a complete amplifier, this is a complete amplifier. This is not a amplifier. Sometimes I ask you to draw a amplifier and you draw the small signal model. This is a AC equivalent circuit, not the amplifier, right. This is a part of a amplifier. So, always understand these things, that what to draw. If I ask you to draw a DC circuit and if you draw the AC circuit, this is wrong. If I ask you to draw the AC circuit, if you draw the DC circuit, this is also wrong. So, which circuit to draw in which case, that you should understand clearly. This we already discussed, potential divider bias, 2 power supply bias, collector feedback bias. So, all of this you have learned in your basic electronic class. So, I will just request you to have a recap. This is a current source bias, and we discussed last day about the current mirroring. If we get time, we will also discuss this in MOSFET, current mirroring. Now, this is our 3 basic configuration. Okay. Can you tell me, is this a complete amplifier? No, it is not a complete amplifier. So, if I ask you to draw a common base amplifier and if you draw that, you will get a 0, because this will not work. Okay. This is an AC model, not the complete circuit. So, complete circuit you need to draw like this or like this. Okay. So, always assume that you have to add all these DC bias on the AC circuit. So, the AC circuit is a equivalent circuit, you have to add all the DC bias. So, maybe you have to add the potential divider here. Okay. This resistance is connected here, it will actually be here. Okay. So, this modification you should be confident to draw. Okay. Understand, please understand this. This is not the real circuit, this is AC equivalent circuit. Actual circuit is like this. Similarly, here this is like this. So, it should be like this, and this is connected to ground. Okay. Input source is here. So, you have to take care of all of this. Maybe you need to give a potential divider here and a DC source here also. So, all of this you should take care of. So, from this we already studied in details, right. So, can you tell me, if I look from this side, what is the input impedance I am seeing? This is R pi. What is the output impedance I am seeing? RC, or sometimes I can tell RC parallel R naught, right. So, I am seeing here RC if R naught is infinite, or if R naught is not infinite, that I will see. Clear? What is the gain here? Minus Gm RC, if we neglect R naught. If we consider R naught, what will be the gain? Okay, this is done. Now, you see in the common base, where is the input? Input is at the emitter terminal. So, that base is common to the input and base is common to the output. So, both of these case output is taken from which terminal? Collector. So, what is the output resistance that you see? Same thing. So, if you see this RC, here also same circuit, right, output you are seeing RC. So, output resistance is, this is output resistance. If you consider R naught, it will be RC parallel. Clear? Now, you see input side, where is the input? emitter. Previous case, where is the input? Base. Which resistance is higher, base resistance or emitter resistance? Base resistance is higher, because base current is lower. So, which resistance, input resistance is smaller? Common base. If I ask you, among these two configuration, common emitter and common base, which amplifier having low input impedance, then what will be your answer? Common base. Why? Because input is now in the emitter terminal. In emitter terminal, what you see? RE. In this you see R pi, but in this you see RE, and RE is always less than R pi. Clear? Third case, common collector. Input is connected to the base, same like common emitter. So, it is seeing what it is seeing? R pi. Now, see difference, common collector. Collector is common to the input, collector is common to the output. So, which is your output? Emitter. So, difference between common emitter and common collector you understand? In common emitter, output is taken from the collector side, emitter is grounded. It is grounded, in reality will it be ground? It will be actually VCC. This is AC ground, not the real ground. This is actually, it should be maybe with a resistance, it should be connected to VCC. So, now what is your output resistance? RL plus RE. Previous case, what was your output resistance? RC. Now it is RL. So, if you, so this is output resistance is smaller than collector, right. So, all of this will affect our how we can behave this. Okay. So, let us see. So, this is our common base amplifier, clear. So, input is given to the emitter terminal, right. So, what is your VB? 0 minus Vi is equal to minus Vi. What is your output? V0 is equal to minus IC RC. Now, you see this minus sign at the minus of Vi will actually cancel this minus of IC. Twice you will get the minus, na. So, you see your output voltage is minus IC RC. IC you replace with IE, alpha IE, and your IE you can calculate like this. Okay. I is equal to VB by RE plus RC, and this minus sign will cancel out this, and you will see that this A0 is also GM RC. In common collector, what we found? AV is equal to minus GM RC. So, this will also give you the same expression, but with a positive sign. So, you see this IC is, we are writing in terms of alpha IE RC. What is my IE? IE is Vi by alpha Vi by RE. Okay. Let's just write it completely. What is our output? The current flowing through the resistance. This is our output. What is the current? IC minus IC. We will write this IC in terms of IE, alpha IE. And what is IE? IE is equal to Vi by RE. This is our resistance, this is our voltage Vi, and if we neglect, suppose this is our voltage Vi, and what is the resistance? RE. Base is already grounded. So, this voltage is actually Vi minus 0. So, Vi by RE, clear. So, alpha into Vi by RE into RC. So, what will be my AV0? V0 by Vi. So, divided this with Vi. So, what you get? And here actually you see it will be actually minus Vi, because it is base is 0, emitter is Vi. So, base emitter is minus Vi. This is IE is equal to VBE by RE, VBE is equal to minus Vi by RE. So, this minus sign and this minus sign, they will cancel each other. So, it becomes alpha by RE into RC. What is the meaning of alpha by RE? GM. What is my output terminal? This is my output terminal. What should be the voltage? Ohm's law. The current flowing through this resistance into resistance value. What is that? Minus IC into RC. So, you just write down. Any other resistance is there? No. So, only this and this is coming in parallel. So, whatever the drop in this resistance, that will be your output voltage. So, what is your output voltage? Minus IC into RC. Okay. Now, this current is flowing through this and this is your IE. What is your IE? What is the emitter resistance here? RE, and suppose this is your Vx. So, VB is equal to Vx, say, is equal to base voltage minus emitter voltage. What is emitter voltage? Say Vi. So, VB is equal to minus Vi. So, what is my IE? VB by what is the resistance? Small re is equal to minus Vi by Re. So, you put that here. So, your V0 is equal to minus IC RC. Please note down this step, is equal to minus alpha I RC is equal to minus alpha I, you replace this equation, minus of Vi by Re into RC. So, it becomes alpha by Re Vi RC. Alpha by Re is my GM, GM RC Vi. So, AV is equal to V0 by Vi is equal to GM RC. So, the expression of common emitter and common base are same. So, what are the takeaway? You see, if you see the overall gain means I have calculated in terms of Vi. I can replace this Vi in terms of Vsig, then it will become a overall gain, right. So, you just calculate what is the Vi in terms of Vsig, just like a potential divider case. So, what you will see that we told you na, that get cancelled out. So, this will be remaining only alpha, and alpha is nearly 1. So, the dependency on beta is less in terms of common base. The first point you see, gain is independent of beta. This gain is overall gain. This gain means V0 by Vsig, not Vi. Vi is my internal voltage. Actual voltage is here. Okay. So, this is first point. Second point is my input resistance is small. In which amplifier you prefer small input resistance? Voltage amplifier, op amp. Input impedance high. So, which amplifier should have a low input impedance? Current amplifier. Input side, it is coming as a current branch, right, in the emitter current flows. So, this can behave like a current amplifier, okay, because this is satisfied, input impedance is low. Why low? Because it is in the emitter terminal. Output resistance is high. So, you see these 2 points satisfies my current amplifier. Okay. So, this can work as a current amplifier, this gives a positive voltage gain. This can be used as an intermediate block for high frequency amplifier. Okay. So, we will conclude here today, and we will continue in our next class.